Alright, so in this video we'll try to work out the foot of the perpendicular from the point -1, 3 to the line 3x minus 4y minus 10 equal to 0. Right, so it helps if we draw what we're actually working out. And the first thing that we can do is draw the line. Here I've drawn it before as 3x minus 4y minus 10 equal to 0. We can have a point, say P, from which we choose to drop the perpendicular to the line, and with a change of color I can draw out the perpendicular that I wish to draw, and finally that yields the foot of the perpendicular, which is the point F, and I should call it x sub f comma y sub f. So we want to evaluate what f would be, and in order to do that we need to recall our previous equations to evaluate the coordinates of f. And if you look at the previous videos, we had found out that our coordinates are related by the following relation. So xf, that is the x coordinate of the foot of the perpendicular, minus x sub p divided by the coefficient of x should be equal to y sub f minus y sub p divided by the coefficient of y in the line, and that is b, must be equal to, well, this is the tricky bit, it's a times the coordinate of the point from which we want to draw the perpendicular, that is x sub p, plus b times y sub p plus c, divided by a square plus b square. So if we remember this, then we can evaluate the coordinates y sub f and x sub f right there. Right, so a couple of things to note here is, let me change the color. A couple of things to note here are the fact that first of all, if you look at this part of the equation right here, this is nothing but the equation of the line with x comma p, x sub p and y comma p substituted, rather than the normal variables x and y. So usually we write the equation as ax plus by plus c equals 0, where a is 3 here, b is -4, and c is -10. And writing it like so, we can actually call this to be represented using a function, let us call it s of x and y equal to 0. This gives us the equation of the line, where s is 3x minus 4y minus 10 in this case. Therefore, if we wish to write axp plus byp plus c, then that can be replaced by s of xp comma yp. And if we write that, then it's an easier way to represent and remember the form to evaluate x sub f and y sub f. So let's try to evaluate what these are, and let me write their relations now. Therefore, our variable x sub f minus, well, x sub p is the x-coordinate of the point, which is -1, divided by the coefficient of x in the expression of s, or the equation of the line. So that's 3 there. Should be equal to y sub f minus the y coordinate of the point P, which is 3, divided by the coefficient of y, which in this case is -4. Should be equal to negative. Now this is where s of x comma p, p comma y p comes into play, and we write that as follows. So 3, that's the coefficient, multiplied by x of p rather than the normal x, because we choose to evaluate this expression at a particular point, and the point is the point P. So rather than x, we would substitute -1, as was done here. Rather than x, we had x of p, and we add that to the coefficient, well, that's -4, multiplied by y, and rather than y, we would have y of p, and y of p is, well, 3. We add this to the constant term, which is -10. So that's basically the equation of the line, 3x minus 4y minus 10, and rather than x, we substitute -1, and rather than y, we substitute 3. And if you do that, you will end up with this expression right there. Well, now, once you've done that, we must divide it by a squared plus b squared, and a squared plus b squared are the sums of the squares of the coefficients of x and y. So the first term is a squared, which is 3 squared, plus -4 whole squared, that's the coefficient of y. Solving this a bit more, we get x sub f plus 1 by 3 equals y sub f minus 3 by minus 4 equals, well, negative of, if you evaluate this as negative 3, negative 12, and negative 10. So that makes negative 3 plus minus negative 12 minus negative 10. So that's negative 3 minus negative 12 minus 10. If you add this up, this gives you 25 with a negative sign, because 3 plus 12 is negative 15, and negative 15 minus negative 10 is negative 25. So that's negative 25 right there. Divided by 3 squared is 9, 4 squared is 16. You add them up, you get 25. Now a negative and a negative cancels out to give you a positive, and a 25 and 25 cancels out to give you a 1. Therefore, if we consider the first relation here, then we have x sub f plus 1 by 3 equals 1. And the second relation, if we consider that, the one that relates y to the constant, then we have y sub f minus 3 by minus 4 equals 1. Solving this yields y sub f equals negative 4 plus 3, or negative 1. And solving for x, we get x sub f plus 1 equals 3, or x sub f equals 3 minus 1, or 2. Therefore, we have now found out the values of xf and yf. So all this helps us to evaluate the foot of the perpendicular, which is located at 2, 1, 2, negative 1. In fact, because you have a negative 1 there. Now, another good check that we can do at this point is to see whether the point lies on the line. It's always good to do checks if you are attempting a question or basically working in learning mathematics. So the check here is that let's see if the point 2, minus 1 lies on the line. So if we have 3 times 2 minus 4 times minus 1 minus 10, let's hope that that should be equal to, well, 0 if it has to lie on the line. We can evaluate this. This gives us 6 minus, and this gives us 4 minus 10. Well, this is minus 4 actually. So this gives you 6 plus 4 minus 10, which is 0. So this indeed is equal to 0, and that is to say the point very well lies on the line. Right, this was check 1. The other check that we can do, even though it's unnecessary at this point, would be to see if the slope of the line, say this line right there, if the slope is minus 1 divided by the slope of the line, because these two lines are perpendicular to each other. So the slope of the green line here, of say the green line, I'm going to write it just by a dash, would be equal to, well, 3 minus 1, difference of the y coordinates, divided by minus 1 minus 2. So that would be 4 by minus 3. And the slope of the line should be, using this equation, we can see the slope of the line expressed in blue would be, well, the coefficient of x when y is the subject, and the coefficient of y is 1, sorry. So in order to do that, we need to, well, I'll work that out. So that's like so, equal to 0. Let's make y the subject of the equation for y equals 3x minus 10. I just shifted it there. Divide everything by 4, and this leaves a 1 there. So y equals 3 by 4, x minus 10 by 4. The coefficient of x here is 3 by 4. Now, that is the slope. Therefore, we can now check whether these two multiply together to give you negative 1. And if you see the 3 by 4 multiplied by, well, 4 by minus 3 indeed gives you negative 1. That is to say that these lines are in fact perpendicular to each other. So that's all. That was the check 2 that we actually performed. And that's all that you need to know if you wish to find out the perpendicular of a point on a given line. And we did that using the formula that we derived in the previous video. And we performed 2 checks to be sure of the answer. So I hope this helps, and all the best.